Okay, so now we're going to solve a linear inequality. These are going to be things that look very similar to the equations. Just notice that instead of having an equal sign, that we have either a less than sign or a greater than or equal sign or something similar to that. So let's actually talk what it means to be a solution of just something as simple as this, where we don't actually have to do any algebra to solve it. So it says x less than 12. Make sure you understand that this is less than and not a greater than symbol. Okay, so what does it mean for x to be less than 2? So we could plot that on a number line. Here's our number line. We'll just put the number 2 here somewhere. There's our number line. And let's see where 2 is. Well, 2 is right here. So where are numbers less than 2? Well, you should know that numbers down here are less than 2, right? Like, let me change the color. Right? 1 is less than 2, 0 is less than 2, -1 is less than 2, -2, etc. are all less than 2. Numbers up here like 3 and 4 are not less than 2. So we don't want those. We want the numbers that are less than 2. But we also have to remember that all the numbers in between the ones that I wrote. So it's not just 1 and 0. What about a half, which is right about here? What about negative a half? What about negative 3.756? It's down here somewhere. So we have to include all of those. So where are numbers really less than 2? Well, you can't just put a dot somewhere because that's not going to just cover anything. So we do that by saying, well, everything less than 2 is to the left. Now, so we're going to make an arrow right on our number line. We're not going to make it too thick and crazy. And then we're saying everything in this direction, all the integers, all the rational numbers, the decimals, the fractions, everything to the left of 2 is going to be less than it. And if you're not sure here, let's take a look at that -2. And we learned what a solution to an equation was. So let's check the solution of, say, -2. So or question mark. Let's check -2. So let's plug it in. So we plug -2 into the inequality, and it gives us -2 less than 2. Is that true or false? Well, that's true, right? So that means -2 is a solution, right? So really, any number you put in here that satisfies that inequality will make it true. So that's everything to the left of 2. Well, what about 2 itself? Let's check, is 2 a solution? Right? So now we're checking. Let's check the number 2 itself, and let's plug that in. So we have 2 less than 2. Now, if this were an equal sign, everything would be great. 2 does equal 2. But is 2 less than itself? And actually, it's not. That's false. A number is never less than itself. It's never greater than itself either. It's only equal. So this statement is actually false, which means that 2 is not a solution of this inequality. So now what we indicate here is, and I think a lot of you know this, so the arrow, right, represents everything less. But we have to somehow signify that we're kind of at 2. So what we do is we put an open dot, don't make it too large, and we put it right on 2. So that open dot means we're not including 2, because we just saw down here that 2 doesn't work. But we are including by the arrow, right? And this shaded part indicates everything less than 2. All right, let's try to do this other one, number 2 here, maybe a little bit quicker. So again, let's get out a number line, and let's see what that means. I'll just put a 2 in, and a couple other numbers. You don't need many numbers for your number line. You can get away with a few. But you have to put some, otherwise it's not a number line. Okay, so now we're looking at that this symbol is now greater than or equal to, greater than or equal to, symbol All right, so like the inequality symbol we had over here, we're going to be shading a particular region. So this question really is asking, where are all the numbers, we'll call them x, where are all the numbers that are greater than or equal to 2? Well, we should know 3 and 4 and 5 are greater, but also 3.5, 4.5, 7.963. So all of those are greater. So we indicate all those numbers that are greater than 2 by an arrow. So a shaded region, and I'm not doing too good with my little drawing tool. And we indicate with an arrow that that graph goes on forever. But now, since we're actually equal to is okay, meaning what happens if we plug 2 into the inequality? So 2 greater than or equal to 2. Now I'm about to ask a question here, and you have to either answer it true or false. Okay, so the question is 2 greater than or equal to 2, true or false? Well, it's true. It is greater than or equal to because of the equal to part. It is true. So that means 2 is the solution. 2 is good. So we need to indicate that. And as far as on a number line, how do we indicate that something is true? Well, we shade it, or just to indicate that we're at the end of the shading, we just make a small dot. We don't make it too large. We just say, yes, we're including the number 2 in addition to all the ones greater. Okay, so there's a less than 1, there's a greater than or equal to, and that's the basis for how we're going to solve things in the examples coming up. All right, so here's some inequalities. They're going to be solved very similar to what we did with the equation. So let's just get to it. All right, so this is really just the normal two-step equation. Not too much going on. Everything looks like it's simplified on each side. So let's go ahead and solve. So let's add 5 to both sides. Okay, those cancel. We're left with 2x. We have less than or equal to. Negative 3 plus 5 is 2. Hope we didn't need a calculator for that. And then dividing both sides by 2 gives us x less than or equal to 1. Okay, now that would be considered the algebraic way to solve this inequality. And just to kind of get an idea of what we're really talking about, we can make a number line. Let's put a couple numbers up. All right, so where are the numbers less than or equal to 1? So we can go right to the 1. If it's less than or equal to, we put a dot on that, and then we can indicate everything to the left because it says less than as well. So remember, the dot is the or equal to part, the arrow is the less than part in there. And try to make your graph look just like mine. Don't put the dot up here, don't put the arrow above the number line. We're graphing on a number line, not above it, not below it, and you make a dot. Don't make a box. Don't make this a skull or a heart. You make it a dot. Okay, number 2. All right, so now this one, we notice that it has x's on both sides. So let's look at the smaller one. This is the smaller one. So we're going to add 5x to both sides. And over here we get 8x plus 5 less than or equal to, let's see, we got 21. Okay. All right, let's see. So we're going to subtract 5. And this cancels, leaving us 8x less than or equal to, let's see what that's, 16. And dividing by 2 looks like, or sorry, dividing by 8, getting ahead of myself, looks like x is less than or equal to 2. Okay, and then a number line answer. All right, we got a dot on 2. And everything to the left of that. There we go. Okay, number 3. All right, we're adding 4 here. So we got 18. Now, right here then, and we should know this, and I'm sure a lot of you remember this. When you have an inequality and you divide by -3, or any other number, negative number, or you multiply by a negative number, you're going to have to flip this sign. So that's why I'm indicating in red here that I'm dividing by -3. So after this cancels, here we're left with x, and then we're going to immediately flip this sign to a less than symbol. Okay, and then that will be, what, -6. And then we can graph that. Now that is going to be an open dot on -6 because it does not say or equal to. And then we're going to graph everything to the left. And all these are to the left. I think the last one is a left too. So I just made these up. Maybe I'll need to, let's change this one. I don't like this one right here. Let's actually change that just to mix it up a little bit. And you'll see why I'm changing it. All right, we'll start with a less than or equal to. There we go. Not a problem. Okay. So subtracting 7. Okay, those cancel, leaving -1/2 x. And less than or equal to -10. All right, now we have a half out here. If you remember from one of the other units, I did a couple of problems like this where we had a fraction out here. And if you remember, we can put that -1/2 in parentheses if we want. And we're going to multiply both sides by the reciprocal of that number. So the reciprocal of -1/2 is -2. If you want, you can write -2/1. I am not going to do that. Okay, because I know the 1 is there. I just don't need it there. All right, so let's cancel appropriately here. So that -2 is going to cancel really that 2 and that negative, right? Because 2 negatives make a positive. And then what are we left with here? We're just left with x. So that's the goal of that, to get x by itself. I think that forgot to change. I already changed the color, but it stayed green. Okay, never mind. So a 2 cancels a half because 2 times a half is 1, and negative times negative is a positive. So we're left with 1x. So there we go. Now, also, I forgot. I multiplied by a -2. Therefore, we have to flip this sign. And that's why I changed it, because I knew it would flip. And one of these problems had to be greater than. So let's make it this one. And then over here, we have a -10 times -2 is a +20. And let's graph that a while. Okay, so this says x greater than or equal to 20. So the or equal to part, if you want to be equal to 20, you make a dot. And if you want to be greater than 20, you go to the right. And there you go, and we're done with those. Okay, now I'm actually going to show you something that's actually pretty new. It's probably the newest thing so far this year. And I'll tell you why we're going to do this. You probably have not seen this. I don't believe you have seen this, especially if you've taken on-level Algebra 1 and Algebra 2. It's something called interval notation. It's a different way to write inequality inequalities and their solutions. Now, we're learning this because we're in college math, and every one of you watching this video and taking this class is now in college. And if you had to do inequalities in college, and let's say you got to in a college algebra class or a say a pre-calculus class, this is how you would answer it anyway. So let's make sure we can actually do this. Okay, so each one of these I'm going to first write as a graph. Now, right now, you would call this algebraic notation. So if you see x's, this is basically algebraic notation. Everything you see here is algebraic notation. What I'm about to draw now is like a graphic notation, meaning I'm taking the same idea, all x is greater than 2, and I'm going to take it from an algebraic view to a graphic view. Graphic just meaning I'm drawing a picture. Now I'm going to make these graphs a little quicker without all the numbers just for time's sake. But let's take a look at what x greater than 2 looks like. We're going to just mark that 2, and I'm not really going to worry about all the numbers for now. We're going to put an open dot, and we are going to graph it like this. Okay, now before I show you what interval notation is, I'm going to quickly graph number 2 as well, so we can talk about these kind of at the same time. That was an awful line, but I'm doing the best I can. All right, so this one gets a solid dot. So that's really the only difference between these two. Wow, I went right over that line. That's weird. I feel like it knew it went that way. Okay, weird. Okay. Just draw a better graph than me. Okay. So here's what we're going to call interval notation. It's not what we're going to call. This is what it is. So interval notation. In all these cases, the notation, let's actually spell that correctly, huh? Okay, notation. Okay. This is what interval notation is going to look like. You're going to put the leftmost number in our solution on the left. So if we look at the blue part of the graph, that's actually our graph, not the number line. But our graph goes from, starts at 2, so let's write that down. It starts at 2, and then we put a comma. And then we say, what is the biggest number in our set? Well, that arrow goes on forever. It goes forever to the right. So that actually goes to infinity. So we write 2 comma infinity. Okay, and then you just encase those two numbers. You put those numbers in parentheses. Okay, so that means from 2 to infinity. Now I want to show you interval notation over here, and it's just going to be a little bit different. It still starts at 2, so I'm going to write 2. And it still goes to the right forever, which is infinity. And I'm still going to put a parentheses, but on this side, notice the difference is that if we want the number, if it's a solid dot on 2, we are now going to make it a bracket, which is square, instead of a parentheses. And when you're giving your answers, make sure that I know the difference between your parentheses and bracket. A lot of times students draw them very similar. Make sure I know the difference, or it might get marked wrong. Okay, let's take a look at number 3. And I think I have enough examples on this page where interval notation is pretty easy. Once you kind of get it, it's actually very easy, I feel. And these should be enough that you get it. Okay, so x less than 2. So we're going to put an open dot on 2. And I'll make this in a different color so we can definitely see it and it stands out. Put an open dot on 2 and everything to the left now. And we're going to put an arrow. Sort of. All right, so when we do interval notation, again, we go from left to right. Never go right to left. We're going to go left to right. So the leftmost number, look at this arrow, goes left forever, right? It goes left, left, left forever. So the leftmost number now, Now, just remember, since we're going left, those are negative numbers eventually. So that is actually going to be negative infinity, comma, and the rightmost number is a 2. Now, for time's sake, I'm just going to say we're always going to put a parenthesis on infinity. Okay, at some point in class, I'll discuss that, but it takes a while, and I don't want you to have to just basically suffer through watching a video getting it. So let's just move along. Notice that if you ever put infinity or negative infinity, just put a parenthesis. Okay, so this one is less than 2, which is an open dot, so we will definitely use a parenthesis on the 2. So these three give a pretty good indication of what you're supposed to do. As far as when you have an arrow. Just remember, open dot is in parentheses, solid dot is a bracket. Put the numbers left to right. You have to go left to right on each of these. Okay, now at some point we're going to run into this, which is called a compound inequality. So let's talk about this. This basically means that x is pinched between the numbers 2 and 5. It's stuck between 2 and 5. So as far as what a graph would look like, let's just quickly graph the number 2. We'll graph the number 5. And because there's no or equal signs anywhere, the 2 and the 5 will both receive an open dot. And this says that x is between 2 and 5, so we're only going to graph the numbers between 2 and 5. There we go. All right, so let's take a look at what this would look like in interval notation. Well, it's the same. It's exactly the same as above, left to right, as we indicated up here. So it starts at 2. The leftmost number is a 2. And then we're going to go to 5. And there's an open dot on 2, so that will be open. There's an open dot on 5, so that will also be open, or parentheses. Okay. When I look at this, often I call it an open, or a bracket I call a closed interval, sorry, based on whether it's an open dot or closed dot. You can call it. If you hear me use certain terminology, just let me know if you don't understand it. Okay. Here, and also you don't have to necessarily draw a number line if you don't want to. If you can do it without a number line, great. But things will get a little tricky at some point. And sometimes I like to have number lines just to make sure I'm doing things correctly. All right, so the difference between number 4 and 5 is that you notice we have a less than or equal sign here. And let's mark that one up. So the negative 2 is still an open dot. Right? And the 3, because it says x is less than or equal to 3, that one gets the solid dot. And everything in between, just like number 4. Okay, in interval notation, I think that's a negative 2. So we're going to go from negative 2 to 3. And the negative 2 gets the parentheses. Oops. Let's clean that up a little bit. The negative 2 gets the parentheses. The 3 gets the bracket. Okay, so if you look at this parentheses and bracket, I think you can tell which one is supposed to be a parentheses, even though this one's not pretty, and this one is supposed to be a bracket. So make sure yours are similar, that I can definitely tell which is which. Very often, I think the brackets, you write them fast, and they kind of round off a little bit, and they look like parentheses, so be careful. All right, so here's the symbol here. What if we have an equation that the answer, we write this down? Of course, we say that this is all real numbers, so maybe you've never actually graphed that. Let's see, what does the graph of that look like? Well, here's a number line. There it is. And even though I didn't write numbers on there, let's call it a number line. So what does all real numbers look like? Well, that just means you're going to graph the entire number line. I'm not doing a good job of it, but you're just going to draw the whole number line in. You're going to go put an arrow that way, You're going to draw shade in this part and put an arrow. So that means your graph covers the entire number line. Okay, so now we can indicate that in interval notation. Well, again, we're going left to right. So what's the leftmost number? That's negative infinity. And remember, just put in a parentheses. And it goes all the way to the right to positive infinity. And this is what it looks like in interval notation. Okay, so this is how I want you to answer all inequalities from this point. If you've watched this video, you must answer all inequalities in interval notation. I think it's pretty easy. If you have questions, let me know. Or you can also get help from your group members if you need to. All right, let's solve these four in this video. We'll be done here, and we should be able to solve any linear inequality that we run into. Okay, so this side has some parentheses, so let's get rid of those. There we go. Keep this 2x minus 4, excuse me. Let's see here. All right, we got to subtract 2x from both sides because we have x's on both sides. All right, these cancel, leaving here 3x minus 2x is just x. Please don't write 1x there. We're big boys and girls now, so we don't write 1x anymore there. Okay, less than negative 4. And x less than, I guess I better show this right here. Adding 6 looks like 2. All right, so as far as a number line goes, we would say that the answer to this looks something like this. Looks like it's an open dot on 2 with everything less than 2. And you can have that. That's perfectly fine, but I'd like you to start using some interval notation. So the answer is negative infinity to 2, and both of those get parentheses, and that's your answer right there. Okay, let's see. All right, so some interesting things will happen here. All right, so the negative 5 is smaller, so we're going to add 5x to both sides. This side leaves negative 7. This is 3x plus 5. We need to solve for x. X just happens to be on the right and leaving it positive. So we need to subtract 5. And that gives us negative 12 greater than 3x. And we need to divide by 3. Okay, those cancel, and we're left with this. Now this says negative 4 greater than x. Well, I think a lot of us don't understand what that means when the x is on the wrong side. So I think it'll be easiest just to flip this guy. Now, so what I'm going to do is take the x, put it over on the other side. But you have to notice that the inequality sign, if you consider it might be like a little arrow, it's pointing at the x. So if you flip this, and if you want to, it still has to be pointing at the x when you flip everything, and then the negative 4 can go over there. Don't ever just flip an inequality left to right without flipping the inequality symbol itself. Okay, so see what I did there. Make sure you do that. And just quickly, if you want to draw a number line, just to help, here's a negative 4. So where is x less than negative 4? Well, that's going to be an open dot, and everything to the left. And we're going to write that in interval notation, which is negative infinity to negative 4. And that has parentheses on both sides. And there's our answer. Okay. This one, we have some distributing to do to get rid of the parentheses. Let's do that. And I see x's on both sides. Now, this looks like one of those special cases, but we have to be very, very careful here to make sure that we answer this correctly, because it's a little bit different than an equation. So those both cancel, and we're left with -5 on this side, and we're left with a -12 on that side. Now, when we had an equation, right now we would say no solution, right? If we had two different numbers on both sides, because there's no way -5 can equal -12. So we would say no solution. But the problem here is that it's not just an equal sign. It's a greater than or equal to. So then we have to ask, is -5 greater than or equal to -12? Well, since these are both negative, -5 is greater than a -12. Because the bigger negative you go, the smaller you are. So again, the question is -5 greater than or equal to -12? And you have to say that that's true. Now, when in equations, when all the x's cancel out like this, the answer was either all real numbers or no solution. So if you remember, when you got a true statement, the answer is all real numbers. And that's what happens here. This inequality, the way it's written, when you solve it, it produces a true statement without any x's anywhere. So the answer is all real numbers. Now in this case, you have the option of answering it either way. There's no need, and also it wouldn't be the best answer if you write it both ways. You can either answer it all real, or you can answer it -infinity to infinity. Okay, pick one. Okay, don't write both. Okay, pick one. I don't care which way you use, just pick the method that you like better. All the other ones we're going to answer with interval notation though. Okay, last one. Looks like the right side has some cleaning up to do, so we'll leave the left side alone. X plus x gives us 2x, and we still have a -5. So notice that the x values are the same, so we're going to end up with a special case, subtracting 2x from both sides. So both of those are canceling, leaving -3 less than -5. And just like number 3 over here, just because the numbers are on different side, or the numbers on the different sides are different numbers, you can't just assume it's a no solution case. You have to look at it carefully with an inequality to determine if it's always true or always false. Okay, so is -3 less than -5? So you would say no, that is false. Okay, and therefore it's just a no solution case. So even an inequality can have a no solution or an all real case like this. And we're done with that one.